Hello guys! So welcome sa second part ng ating topic about sa analysis of doubly reinforced beam. So bali no, in this video guys ay magsosolve tayo ng problem. This is an example problem number 1. SI siya na problem guys. So ayun, so isolve natin to guys. No? So determine the design moment capacity of the beam shown in the figure for which the F sub y is equals to 413.7 megapascals and F sub c prime is equals to 20.7 megapascals. So ayun guys, so i-solve natin to guys. So bali no, ang una natin gagawin of course is kailangan nating ilista muna lahat ng ating mga given. So yun, so bali no, given guys yung ating F sub c prime at saka yung ating F sub y. So bali no, yung ating F sub c prime na is 20.7 and yung ating F sub y is 413.7 megapascal. Tapos given guys yung ating B which is the width nga ng ating beam. Rectangular lang naman yung ating beam. Tapos given yung ating effective depth. So again yung ating effective depth guys is mula sa extreme compression fiber papunta dito sa centroid ng ating steel which is 537.5 plus 62.5, so that will be 600 millimeters. Tapos of course, given din yung ating D prime is the distance ng ating compression steel bars, ng ating centroid ng compression steel bars papunta sa may extreme compression fiber, so that is 62.5 millimeters. Okay, so ngayon guys, no, i-compute muna natin siguro yung ating mga area ng ating steel bars bago tayo mag-proceed sa ating analysis. So, of course, meron tayong dalawang sides dito, guys, no? Meron tayong dalawang sets ng ating steel bars. So, ito yung ating area ng ating compression steel bars. Tapos, ito naman yung ating gagamitin sa pag-compute ng ating area ng ating tension steel bars. So, bale, para sa ating area ng ating compression steel bars, dalawang 28mm diameter. So, bale, ang lalabas dyan na value ng ating AS prime. So, take note guys ha, AS prime yung ating symbol para sa area ng ating compression steel bars. Okay. So, bali no, para naman sa area ng ating tension bars, that is AS, that is apat na 36mm bars. So, ayun. So, bali ang ating AS will be equal to 4,071.5 square millimeters. Okay. So, ngayon guys, na-compute na natin lahat ng ating mga kailangan. Pwede na tayong magsimula ngayon ng ating analysis ng doubly reinforced beam. So una, ang gagawin natin guys is gagamitin natin yung equilibrium equation ng ating beam assuming that F sub S prime is equals to F sub Y. So bali no, dito, by using this guys, no, bali ina-assume natin na yung ating compression steel will yield. Okay, so take note guys, yung ating F sub S prime dito is the stress sa ating compression steel bar. So kapag ka nag-equal siya sa ating F sub Y, then that means nag-yield talaga siya. Okay, so ang gawin muna natin guys is gumawa tayo ng force diagram. Diba nga kapag gumawa tayo ng force diagram, yung ating tension force is nilalagay natin sa centroid ng ating tension area. So bali ito na nga yung guys, that is T is equals to AS multiplied by F sub Y. So yung AS dito is the total na area sa ating tension side. Okay? Tapos of course, meron tayong compression force, that is compression concrete. No? Take note, the compression concrete will act at the centroid of our area ng ating compression concrete. So, rectangular man lang yung ating beam. So, ibig sabihin, dito siya mag-act sa gitna. So, therefore, yung ating distance between tension force and our compression concrete force is equals to D minus A over 2. So, of course, meron din tayo, guys, force na galing sa ating compression bars. So, ito na nga yung compression steel which is equals to AS prime multiplied by FS prime. Okay? So, again, guys, no, ito is F1 yung ating ginamit kasi nga dun sa may tension side, no, laging nag-yield dun yung ating steel bars. Pero dito sa ating compression side, no, F sub S prime yung ating ilalagay dito kasi may possibility na hindi siya mag-yield. Okay? So yun nga guys, no, so of course yung ating distance na ating compression steel mula sa ating extreme compression fiber is yung D prime. So ito na nga guys. Okay guys, so yung ating magiging equilibrium equation is tension force is equals to compression concrete plus compression steel, no? Kasi nga, ito lang naman yung tension, tapos ito is parehong compression. So, ayun. So, bali, no? Ang mangyari dito, guys, ilagay natin dito yung mga formula nila, guys. So, bali, ASFY yung ating T, tapos 0.85 F sub C prime AB yung ating compression concrete, and then AS prime FS prime yung ating compression steel. So, take note, guys, na dito, no, i-assume muna natin that the FS prime is equal to F sub Y. So, ibig sabihin, ang gagamitin natin guys na F sub S prime is equals to F sub Y. So, ayun. So, bali, no, kapag ginawa natin yan, guys, no, ang mangyayari dito is yung A na lang yung ating magiging unknown kasi yung iba ay given na lahat. So, ayun. So, bali no guys, kapag kinompute natin si A, ang A ay magiging 190.79 millimeters. Okay, so ngayon guys, no, i-compute natin guys yung ating value ng C which is equals to A over beta 1. So, ibig sabihin kailangan natin guys ng beta 1 at of course, gagamitin natin dito yung NSCP 2015. So, according sa NSCP 2015, yung beta 1 is nakadepende nga sa ating value ng f sub C prime. So, ilan ba yung ating f sub C prime? That is 20.7 megapascal. So, ibig sabihin guys, dito siya nabibilong. Ayun. So, ibig sabihin our beta 1 will be equal to 0.85. Okay, so of course, kapag kasi substitute natin guys yung beta 1 at saka yung A dito, yung ating value ng C will become equal to 224.45 millimeters. Okay, so ngayon guys, na-compute na natin guys yung A at saka C. So ang next natin na gagawin is kailangan natin i-find out kung tama ba yung ating assumption na mag-yield si compression steel. So we will compute the strain in compression steel, that is epsilon sub S prime. That is to verify the assumption that the compression steel yields. Okay, so bali no, gawa muna tayo guys ng strain diagram. So bali sa ating strain diagram, ito na ngayon yung ating strain diagram guys, no? So yung ating strain sa concrete is 0.003. Tapos, ang tawag natin dito sa strain na to is the compression steel strain. So ito yung i-compute natin. Tapos obviously, ito yung ating tension strain. Alam na natin ito, no? Kasi lagi na natin siya kino-compute before sa singly. Okay? So, ilagay din natin guys dito yung ating mga dimensions. So, ito yung ating C tapos D. Tapos ito yung ating D prime. So, ito ay magiging C minus D prime. Okay? So, ayun guys, no? So, paano natin malalaman kung yung ating compression steel strain, kung yung ating compression steel ay mag-yield or hindi, no? Base sa ating na-compute na compression steel strain. So, ang gagawin lamang natin guys is i-compare natin si compression steel strain kay epsilon y, that is yield strain guys, no? So, balik kung yung ating compression steel strain is greater than or equal sa ating yield strain, then that means nag-yield talaga guys yung ating compression steel. Pero kung naging less than siya sa ating yield strain, then that means hindi siya nag-yield. So, ayun. So, okay. So, ang gawin natin guys, ratio and proportion lamang. So, itong triangle na to na red is similar to this triangle na orange. So, bali no, ratio and proportion lang guys, 0.003 na side divided by C is equals to compression steel strain na side, epsilon sub S prime divided by C minus D prime. So, bali, ang lalabas dito guys, na ating compression steel strain is 0.002165. Okay, so ngayon guys, no, i-compare natin siya sa ating yield strain. Pero wala pa tayong yield strain, so kailangan muna natin i-compute si yield strain. So, para sa pag-compute ng yield strain, madali lang naman, that is F sub Y divided by the modulus of elasticity ng steel. So, yung F sub Y natin is given sa problem, guys, that is 413.7. Nandito nga yung sa table kasi given nga siya sa problem. Tapos, obviously, di ba constant man yung ating modulus of elasticity ng steel, that is 200,000 megapascal. Okay, so bali guys, yung ating yield strain ay magiging 0.002069. So ngayon guys, ay compare natin si compression steel strain sa ating yield strain. So bali no, take note that 0.002165 is greater than sa ating yield strain. Tama ba? So bali ang mangyayari is, it is yielding. Okay, so dahil nga mas malaki si compression steel strain kesa sa ating yield strain, then ibig sabihin nun that the compression steel is yielding. So, ang ibig sabihin nun guys, that the F sub S prime na in-assume natin kanina is really equal to F sub Y. So, tama yung ating naging assumption kanina guys. So, the assumption was correct. So, ngayon, i-continue na natin guys. So, dahil tama nga yung ating assumption, then yung na-compute natin kanina guys, na value ng A at saka C, na nandito na nga, di ba, ay tama yun kasi nga tama yung ating ginamit na assumption doon, okay? So, bali no, guys, no, ang gawin natin ngayon is i-compute naman natin, guys, si tension strain. That is, itong nandito sa may baba. Okay? So, tension strain. So, ratio and proportion lamang din, guys, no? So, itong triangle na to na maliit is similar to this malaking triangle. So, ratio and proportion lamang, guys. That is, itong munang malaking triangle, itong side na to is tension strain plus 0.003. Tapos, itong side na to is D, okay, equals to 0.003 divided by C. Okay. So, lahat dito ay nakuha na natin ito kanina, guys. So, bali mag-compute natin dito sa tension strain and that is equals to 0.005019. Okay. So, ngayon, guys, no, kailangan natin gamitin yung table sa NSCP para ma-classify natin yung ating tension strain na to, yung ating beam na to. Okay? So, bali, galing dito sa table, alam natin that our tension strain nga is greater than 0.005. So, ibig sabihin guys, dito siya nabibilong. So, ang ating classification neto is tension controlled at yung ating value ng phi is equal to 0.9. Ito nga yun guys, 0.9. Okay? So ngayon guys, na-compute na natin nga yung ating value ng phi, then we can now compute our design moment capacity which is phi mn. Okay? So ngayon guys, hiniwalay natin guys yung ating, ito yung ginamit natin na figure dun sa ating first na video, no? So, hihiwalay natin guys dito yung ating couple galing sa compression concrete at saka part ng ating tension area. Tapos yung couple galing sa ating compression steel at saka part pa ng ating tension area. So, bali guys, ang gagawin natin dito is i-compute muna natin guys si AS1 at saka si AS2. Okay? So, bali, alam natin that total area sa ating tension side is equals to AS1 plus AS2. Okay? So, bali pwede natin guys, diba nga, yung T2 at saka si CS dito is equal. So, diba, equal man din silang duha. So, pwede natin i-equate guys, AS2 Fy is equals to AS prime F sub S prime. Take note guys, kanina na find out na natin that si Fs prime is equals to F sub Y. So, ibig sabihin guys, kung equal si Fs prime kay F sub Y, then AS2 natin is also equal to AS prime. Kaya makakancel man ning si Fs prime at saka si F sub Y. Okay? So, bali alam na natin guys, si AS prime na compute natin siya kanina pa lang na unang part ng ating solution. So, that is 1231.5. So, ito na nga yung ating value ng AS2. Okay? So, ngayon na-compute natin si AS2, hindi makakompute din natin guys si AS1 kasi alam naman natin na yung value ng AS, di ba? Na-compute na din natin to kanina sa unang part ng ating solution. Okay? So, bali guys, ang mangyayari is AS1 is equals to 2840 square millimeter. Galing dito sa formula na to. Okay? So, ngayon nga guys, na na-compute na natin si AS1 at saka si AS2, then pwede na natin makuha ngayon yung design moment capacity natin, which is yung PMN. Okay, so again guys, yung PMN is simply yung phi multiplied by Mn. Ano pa yung Mn? That is the nominal moment. So yung nominal moment is the total moment na i-resist nga ng ating doubly reinforced beam. So ibig sabihin, yung moment created by this couple na T1 at saka C sub C at saka yung moment created ni T2 at saka ni C sub S. Okay, so bali ang moment created ni C sub C at saka ni T1 is itong moment na to, that is T sub 1 multiplied by D minus A over 2. Okay, so that is yung magnitude ni T1 times yung distance between them, that is D minus A over 2. Pwede din namang C sub C multiplied by D minus A over 2. Okay, tapos yung moment naman na created by T sub 2 at saka ni C sub S is T sub 2 multiplied by D minus D prime. So magnitude ng isa sa mga force, kasi equal lang naman yung dalawang force na yan, multiplied by the distance between them. Okay, so ayun guys, So, bali yung ating PMN is equals to phi multiplied by yung sum nitong dalawa. Kasi yan yung ating magiging nominal moment. Okay? So, yan na nga guys yung ating formula. So, kapag sinubstitute natin guys, so of course, madali lang makuha naman si T1 kasi AS1 Fy. Diba yung AS1 ay nakuha na natin. Tapos, Fy is given sa problem. Tapos, si T2 makukuha din natin siya kasi given na naman, nakuha na naman natin si AS2. Tapos, given na naman din si Fy. Okay? So, bali ang lalabas dito guys is PMN is equals to 780,035,669 Newton millimeter. Okay, so of course, kailangan natin dito na unit is kilonewton meter. So, PMN natin will be 780.036 kilonewton meter. At ito na nga guys, yung ating sagot na design moment capacity sa problem. Okay, so I hope naintindihan nyo guys yung ating solution. So, ayun, so bali para sa problem na to, yung ating sagot dito is 780.036 kilonewton meter. Okay, so sa next na video guys, ay solve natin yung another variation ng problem para sa analysis ng doubly reinforced beam. So sa case na to, hindi mag-yield yung ating compression steel. So ano nga ba yung gagawin natin guys kapag hindi nag-yield yung ating compression steel? So mapafind out nyo yan sa next na video. So that will be the last part of this videos para sa analysis of doubly reinforced beams. Okay? So, shoutout nga pala guys kay Engineer Bevis Sheen Alvarado. Hi, Sheen! So, ayun guys. So, see you sa next video. Bye-bye!